Okay, we've got what's known as the addition and difference angle formula. Basically, what does that mean? It means that, say you've got, say, the sine of A, and you know what that equals, and say the sine of B, and you know what that equals as well. You can use that information to find out what the sine of A plus B is. It's a little bit more complicated than that, but basically that's it. So there are, obviously, for sine, cos and tan, so the sine one, sine u plus or minus v equals sine u cos v plus cos u sine v. The cos ones, cos of u plus or minus v. Actually, I forgot my little bit here, I haven't quite done that right. So if it's sine u plus v, then it's sine u cos v plus cos u sine v. And if it's sine of u minus v, it's sine u cos v minus cos u sine v. So here we got cos u cos v and sine u sine v for the cos ones. Now if it's cos of u plus v, then it's minus, and if it's cos u minus v, then it's plus. And then of course there's tan ones as well. So tan u, again plus or minus v, and what we have is here we have tan u, tan v, and on the bottom we have the 1 and the tan u times tan v. Alright, so if it's tan of u plus v, it's tan u plus tan v over 1 minus tan u tan v. And if it's tan u minus v, then minus on the top and the plus down the bottom there. Alright, so what I'm going to do is rub those out and highlight those a little bit differently. Alright, so u plus v, we've got a plus there, u plus v, we have a minus here, u plus v, we have a plus here and a minus here, u minus v for the sine, there's a minus here, u minus v for the cos, there's a plus there, and u minus v, got a minus here and a plus here. Right, so they're the formulas. Now, if you want to know some proofs of these, then you can do the internet search for proof of. Alright, so one of the places you might find in this internet page here, it will go through. There's a whole bunch of different ways of proving it. Geometric is the usual way. Alright, let's move on to some examples. Okay, so here's an example. If sine A equals 1/4 and cos B equals 3/4, and A and B are acute angles, find sine A plus B. Okay, so the acute angles part just tells you that they're in the first quadrant, and in the first quadrant sine A and sine and cos are both positive. Now, when we're looking at the equation here, we're looking at sine A plus B, which of course is sine A cos B plus cos A sine B. We need to know what cos A are and sine B are. And so we just use the Pythagorean for that. So sine A equals a quarter. Pythagorean says that sine squared, so a quarter squared, plus cos squared equals 1. So cos squared is 1 minus 1/16, which is 15/16. And so cos A is the square root of 15 on 4, plus or minus, as I mentioned up here, A and B are acute, so if they're both acute, positive in that quadrant. So we got cos A is root 15 on 4. We also need to know the B bit, so because we can know that cos B is 3/4. So again, the Pythagorean, so sine squared B plus cos squared B, so that's 3/4 squared, equals 1. So we know that sine squared B is 1 minus 9/16. Okay, so 16 minus 9 is 7. So we've got 7/16. It's not cos, sine. Rid of that. So sine squared B. So sine of B is the root 7/4, plus or minus, again, first quadrant, acute angle. So the sine of B is positive root 7/4. Alright, so now we're going to put that together. Alright, so sine A plus B, as we already said, was sine A cos B plus cos A sine B. So we have the sine of A, which is a quarter, times the cos of B, which is 3/4, plus the cos of A, which is root 15 on 4, times the sine of B, which is root 7 on 4. So we get 3/16, plus 15/7 is 105 on 16. So the only thing really you can do is take 1/16 out as a factor, and you've got 3 plus square root 105. And so there we go. That's that. Okay, next example, we can use that for these formula also to find exact values, I should say, of things that we don't necessarily know by using exact angles of things we do know. Or exact values. Good. So, oops. Here's one. Find the exact value of cos 15, but we don't actually know what the exact value of cos 15 is. But what we do know, which is we know 45 degrees, take 30 degrees, is 15 degrees. So the cos of 15 degrees would be the same as the cos of 45 degrees minus 30 degrees. And so if we use our difference angle formula, cos u minus v is cos plus sine. So it's cos 45 cos 30 plus sine 45 sine 30. And cos 45 is root 2 on 2. Cos 30 is sorry, gone blank here. Cos of root 30 is root 3 on 2. Sine 45, root 2 on 2. And sine 30 is a half. Alright, so then we get root 6 on 4 plus root 2 on 4. And what we can take out here is common factor of root 2 on 4, and we have root 3 plus 1 as our final answer. So by using those two angles there, we've got an exact value for 15 degrees using the exact values of things we know. Of course, 45 minus 30 is not the only way we could do it. We could do it as 60 minus 45 as well. Alright, I'm going to leave that. Actually, I'm not going to leave that to you. There's one more. So there I've used it to expand something. We can use it to simplify something as well. Alright, here's our example. Sorry, it's got a bit squished at the end there. So sine of x plus y on 2 times cos of x minus y on 2 plus cos x plus y on 2 times sine x minus y on 2. So what have we got here? We've got sine cos plus cos sine. So you need to go to your angle formulas there, sum and difference formula, and look and see which one goes sine cos plus cos sine. And when you look at that, that is the sine u plus v1 that we're looking at. So in this case, u is x plus y on 2, and v is x minus y on 2. Alright, so what it simplifies to then is sine of x plus y on 2 plus x minus y on 2. And when you put all of that together on our common denominator, you get x plus y plus x minus y on 2. The y's subtract, so you got sine 2x on 2, which obviously then becomes the sine of x. So we've used the sum difference formula in the opposite way. Alright, so that's it. That's from set number 6. Again, it's from the Maths Dimensions, and that should be in the pack that you've been given.